Euclid Book 4, proposition number 10, and we're going to take this very, very slowly because this is a very long proof, and we may have to do a little cheating on this. I know Euclid would not like that, but Euclid's dead, so we don't care. Anyway, we have a line AB. That's the first thing you're going to draw is line AB, and you have to cut it at C. Now, it's not just at any point you have to cut it. No. By using Euclid Book 2, proposition number 2, you have to make sure that the length of... Okay, now you're going to form a rectangle. Okay? I want you to go on another page. I want you to form a rectangle. Two sides of that rectangle are going to be the exact same length as AB. Two sides of that rectangle are going to be the exact same length as BC. Okay? So the length of the rectangle you're forming is AB, and the width of the rectangle you're forming is BC, right here. Okay? Now, I want you now to make a square, and each side of the square that you make has to be the length of AC. Okay? So the area inside that square of AC must be the same area as the rectangle I told you to make. If it is, then you've cut AB at the right spot, which is C. Alright. Now, you're going to draw a circle starting at centermost part A, outermost part B. You're going to make BDE. There's a great big circle right here. Okay. Now, you're going to draw BD equal to AC. Well, where's BD here? There's BD. It's going to be the same length as AC. How do you do this? By Euclid Book 4, proposition number 1. Now you're going to join AD and DC. Well, here's AD here, and here's DC here. Alright. Now by using Euclid Book 4, proposition number 5, you're going to circumscribe circle ACD, here's ACD, okay, around triangle ACD. Now, I know I have not done this perfectly, but if we had better tools, that's what we'd do. Alright. Now, we've already established that we have a rectangle. Two sides of that rectangle will be the length of AB. Two sides of that rectangle will be the length of BC. So you're going to have a length of AB and a width of BC for your rectangle. And we've already said that the area inside that rectangle that you just drew is the same area as if you had drawn a square with the sides all being the length of AC. Okay? This makes line AC here equal in length to line BD here. Alright. So, we also know now that if you were to form the rectangle of AB and BC, which I described just a minute ago, that area would be equal in size to the area as if you had drawn a square and all four sides of the square were BD. Okay, so if you draw a square and each side of that square was going to be the length of BD, you'd have an area in there that would be equal in size to the area of the rectangle I just described a minute ago. So far, so good. Since point B is taken outside of ACD, well, here's circle ACD, and point B has been taken outside of it. And from point D, two straight lines have fallen on ACD. Well, here's ACD again. Two lines have fallen on it. One line touches it. The other line cuts it. Okay? And we already established that the rectangle formed with the lengths of AB and the widths of BC are equal in size. The area inside the rectangle is equal in size to the square formed by the lines of BD. BD, four sides, area. Got it. Alright. We also now know that BD touches ACD. BD touches ACD. And we know this by Euclid Book 3, proposition number 37. And since BD touches ACD, and DC, here's DC, is drawn across from the point of contact at D, okay, Now I know I don't have this formed perfectly, but this ACD would pass through point C, so there would be a line from D to C, and there'd be two contact points at the circle, so on and so forth. You're getting the idea here. BDC equals DAC. BCD, BCD. Okay, here's BCD. No, I'm sorry, not BCD. Sorry. Scratch that. BDC, this angle right here. Okay? Because of all the other stuff that was true, BDC here is equal to DAC here. DAC here. This angle here are equal. And we can prove this by Euclid Book 3, proposition number 32. And we can go on to say that if we were to add CDA, okay, this angle right here, to BDC and to DAC, okay, if we were to add this to this and this to this, then we could say that BDA, this whole angle right here, okay, was equal in size to CDA and DAC. Well, where's CDA? Well, here's CDA here, okay, and DAC here. So this plus this equals all that. Alright, now let's go back to BCD. Here is BCD. Just like that. This angle here is equal to CDA plus DAC. It is equal to CDA right here plus DAC. These two here equals this here. And because of that, we can then go on to say, and that was because of Euclid Book 1, proposition 32, by the way. So this equal to both of these is Euclid Book 1, proposition number 32, and because of that, we can then go on to say that angle BDA, well, here's B, here's D, here's A, this whole thing right here is equal to BCD. BCD. This here is equal to this here. So far, so good. Now, BDA, this whole angle right here, is equal to CBD, that one right there, okay, and we can say this because AD is equal to AB. Well, this here and this here are equal in length, so this here and this here are equal in size. And we can say this by Euclid Book 1, proposition number 5. Therefore, angle DBA, this one right here, is equal to BCD. BCD right here. Alright. So now we can say that angle DBA, this one here, is equal to DBA, okay, BDA and DBA, these two are equal, and these are also equal to BCD. BCD. That one right there. Okay. That makes line BD equal to DC. Well, where's BD and where's DC? These two lines are now equal in size. Whew. And we're still not done. Almost, but not quite. Okay, BD equals CA. BD, CA. Okay, we pretty much established that at the beginning of the proof. That makes CA equal to CD. Well, CA here and equals CD here. And that makes angle CDA equal to DAC. Well, where's CDA? CDA, this angle right here. And DAC, well, where's DAC? Well, here's D, here's A, there's C. So this one and this one are now equal. And we can say this by Euclid Book 1, proposition number 5. And if we were to add CDA and DAC together, CDA, we would add that one, and DAC like this. We add those two together, we get twice DAC, DAC. Okay? This plus this makes twice of this. Fine. Now, BCD, okay, right here, is equal to the sum of CDA, CDA, this one here, plus DAC, which is this one here, DAC. So this plus this equals this one. This plus this equals this. Therefore, angle BCD, okay, is equal to BDA or DBA. Well, where is BDA? BDA or DBA? Well, where's D? Here's B, here's A. Okay? Now, if you had BDA or you had angle DBA, you would have twice DAB. Well, where is DAB? Here's D, here's A, here's B. You'd have twice of that. And so therefore, what have you done? Well, what you have done is you have constructed an isosceles triangle having each of the angles at the base double the remaining one. Okay? And that is exactly what you have done. I will tell you more in a future video, so stay tuned.